As you might imagine, there are some analogies that help us deal with rotary systems. Working with the things that we've learned today so far, work is equal to force times delta D, but the analogy for force in a rotary system is torque. So work is equal to torque times, well, the analogy for delta D in a rotary system is theta, or delta theta. So if I take the torque and multiply by the change in angular position, I have the work. So that could go in your toolbox along with the linear version. And then power, well, power is equal to force times velocity. So using that equation, power in a rotary system is going to be equal to torque times angular velocity, torque times omega. So also could go in your toolbox. Here's a question. A pottery wheel driven by a concrete disc that has a mass of 50 kilograms. This disc is kicked by a foot on the outside of its 45 centimeter radius. It's an old-fashioned one. If the disc starts out at rest and is kicked steadily for 45 seconds till its angular velocity reaches 80 RPMs, how much work is done? Well, to find work here in this rotary system, we're going to have to take torque and multiply by theta, by the change in theta. We know two things about torque, two definitions for torque. We know that torque could be F times L. We also know that torque could be defined as I times alpha, the two ways to get torque. Well, we don't know any force here on this wheel, so that's probably not going to be very useful. We're going to have to stick with torque equals I times alpha. Well, this is a disk, so I could be quantified this way. I is 1/2 the mass times the radius squared. So that means torque equals 1/2 mr squared times alpha. Now here's the other thing we know. During an acceleration, theta is going to be equal to the initial angular velocity times delta t plus the angular acceleration over 2 times delta t squared. So if we want to find theta here, in this particular system, it's starting from rest, it says, theta is going to be equal to alpha over 2 times delta t squared. So that means work, being torque times theta, is 1/2 mr squared times alpha, that's torque, times theta, which is alpha over 2 times delta t squared. Well, if you put this all together, you find 1/4 mr squared alpha squared delta t squared. Let's see if we can't simplify this a little bit further. I think it might be possible. Obviously, if you really want to quantify this thing, you're going to have to find alpha. You have to find out what alpha is. So alpha is equal to the change in omega with respect to time. Well, let's plug that in there. So that means work, which was equal to 1/4 mr squared alpha squared delta t squared, is equal to 1/4 mr squared delta omega over delta t squared, because that's what alpha is, times delta t squared. So you could say that work is equal to 1/4 mr squared delta omega squared, and the delta t's have canceled out. So here's our equation that will allow us to calculate what work is. The first thing we've got to do is figure out what delta omega is. Radius and mass are given to us, and so that'll be the easy part. So let's find out what is delta omega. Well, the thing started out at rest, and it ended up going 80 RPM. So delta omega is 80 RPM minus no RPMs. So 80 RPMs. That's how much the speed. But we're going to want that in radians per second. So let's take 80 revs per minute and we'll convert. We know that a rev is 2 pi radians. We also know that a minute is 60 seconds. And so when we do this calculation, we find out that 8.38 per second is our change in angular velocity. Well, we were finding that so we could plug that into the work equation. We now know that work is equal to 1/4 mr squared times delta omega squared. Now we know delta omega, so we can quantify this and finally finish this problem up. So it's 1/4 times the mass of the wheel, 50 kilograms, times the radius. Well, the radius was 0.45 meters, 45 centimeters. That's going to be squared, times 8.38 per second, and that's going to be squared. Let's make sure we get units of work here. Well, kilogram meters per second squared is newtons, so this is the equivalent of newton meters, or joules. So we do have work units. Now let's quantify it, find the actual answer. Numerically, it's 178 newton meters.